Imagine you had the chance to watch the longest and most captivating film in history. It spans 4.5 billion years. There are no fictional characters, and the special effects surpass anything you've ever witnessed. The main protagonist of this film is our shared home, planet Earth. And today we're going to watch its accelerated version, from the very first frame captured in cosmic dust, right up to the present day. It's a story of fury and tranquility, of mass extinctions and life's incredible triumphs. This is our story. It all began in a gigantic cloud of gas and dust, remnants of an ancient star's explosion. This cosmic cradle, known as the Solar Nebula, was vast and chaotic. At its heart, gravity drew matter together, heating it to millions of degrees. Thus, our sun was born. Meanwhile, around it, within a colossal spinning disk, something equally significant was taking place. Billions of tiny dust grains and ice crystals collided and coalesced. This process, called accretion, is similar to a snowball rolling down a hill and growing into a massive sphere. First came specks of sand, then pebbles, then asteroid-sized boulders, known as planetesimals. Over millions of years, these planetesimals continued to collide, merging into even larger bodies, protoplanets. The early solar system was a true cosmic billiards game, where colossal spheres slammed into one another with thunderous force. And so, approximately 4,540,000,000 years ago, amidst this chaos, the young Earth took shape. But don't imagine it resembled the blue marble we know today. No, it was a veritable hellscape. Its entire surface was a boiling ocean of magma, heated to thousands of degrees. There was no atmosphere as we understand it, only toxic gases erupting from its depths. And from the sky, asteroids and comets, leftover debris from the grand construction, ceaselessly rained down. Scientists aptly call this period the Hadean Eon, or Catharchian period, a name honoring Hades, the ancient Greek god of the underworld. And just when it seemed the chaos would never end, an event occurred that would shape our planet's future. Roughly 100 million years after its birth, Earth collided with another celestial body. This was a protoplanet the size of modern-day Mars, which astronomers named Theia. The impact was of unimaginable force. It was a glancing impact, tearing a colossal chunk of Earth's mantle free and launching it into orbit. Our planet literally rang like a bell, and its axis of rotation tilted, which is why we experience seasons today. The debris, ejected into space, didn't simply fly away. Under the influence of gravity, they coalesced and formed our faithful companion, the Moon. Its emergence was crucial. The Moon stabilized Earth's rotation, preventing it from tumbling chaotically through space, and caused powerful tides that would yet play a significant role in the history of life. Following this colossal cataclysm, Earth began to slowly cool. The cosmic bombardment began to subside. On the surface of the fiery ocean, a thin basaltic crust began to form, like a film on cooling milk. But this was not the solid ground we walk upon today. Lava flows constantly broke through it, and it cracked and sank back into the magma. The atmosphere was also changing. Volcanoes spewed immense amounts of water vapor, carbon dioxide, and nitrogen. The planet was shrouded in dense, heavy clouds. And when the surface cooled enough for water to remain in liquid form, the greatest deluge in history began. It didn't last for days or weeks. It continued for millions of years. Hot water filled all the low-lying areas, forming the first global ocean. However, it wasn't blue, but rather brownish-green due to the immense amount of dissolved iron and incredibly salty. Thus ended the hellish Hadean Eon and began the Archean Eon, the era of Earth's earliest life. 4 billion years ago, Earth was a water world with small islands of volcanic land. And somewhere here, in this warm, chemically rich primordial soup, a miracle occurred. We still don't know exactly how it happened. Perhaps near underwater geothermal vents, the so-called black smokers, where jets of hot mineral water erupted from the Earth's depths. Or maybe in shallow coastal pools that evaporated in the sun, concentrating organic molecules. Either way, non-living chemistry made a qualitative leap and transformed into living biology. The first self-replicating molecules appeared, followed by the first primitive cells. These first forms of life, our most distant ancestors, were incredibly simple. They were single-celled organisms, similar to bacteria. They lived without oxygen, which was almost absent from the atmosphere at the time, and fed on chemical energy from their environment. All life was concentrated in the ocean, hiding from the sun's destructive ultraviolet radiation, as the ozone layer did not yet exist. For billions of years, nothing discernible to the human eye occurred on the planet. Only microscopic organisms slowly and imperceptibly changed the world. They were the sole masters of the planet. And then, about 3.5 billion years ago, some of them sparked a revolution. These revolutionaries were cyanobacteria, or blue-green algae. They invented photosynthesis, an ingenious trick for converting sunlight, water, and carbon dioxide into energy. It was an incredibly efficient way to obtain food. But this process had a byproduct, one that was very dangerous and poisonous to most of Earth's inhabitants at the time. This product was oxygen. For hundreds of millions of years, cyanobacteria saturated the oceans with it. Initially, all the oxygen was used to oxidize iron dissolved in the water. It precipitated, forming the gigantic layers of iron ore that we mine today. Once the iron in the oceans ran out, oxygen began to surge into the atmosphere. And approximately 2.4 billion years ago, the so-called Great Oxygenation Event, GOE, struck. For the anaerobic life forms that had dominated the planet, free oxygen was a deadly poison. This triggered the first mass extinction in history, one caused by life itself. Up to 99% of all living organisms perished. While it was a genuine ecological catastrophe, it paved the way for the development of new, more complex life forms that learned not only to survive in an oxygenated environment, but also to utilize it for respiration, a far more efficient way of obtaining energy. Earth's atmosphere changed dramatically. It became clear, and in its upper layers, an ozone layer formed from oxygen, which protected the planet's surface from harsh ultraviolet radiation. The path for life on land was open, though another billion years would pass before it was taken. This subsequent billion years is often referred to as the boring billion. It seemed as if evolution had stalled, but this was far from the truth. It was during this period, in the quiet of the ocean depths, that crucial developments were taking place. Eukaryotes emerged, cells with a nucleus and other complex organelles. This was a giant leap forward compared to primitive bacteria. We too are composed of such cells. Furthermore, these organisms developed sex, the ability to exchange genetic information, which dramatically accelerated the pace of evolution. Meanwhile, the planet continued its own dynamic existence. The continents, which had already formed by then, drifted, collided, and pulled apart. They assembled several times into supercontinents like Columbia and Rodinia, only to break apart again. At the close of this boring billion, Earth faced yet another severe challenge. For reasons scientists still debate, the planet's climate drastically cooled. Glaciers began to advance from the poles toward the equator and eventually covered nearly the entire surface of Earth with a thick layer of ice. The snowball Earth era had arrived. The planet had transformed into an icy sphere, reflecting sunlight back into space and cooling it even further. Life clung on only in small oases, around underwater volcanoes or in cracks in the ice where sunlight could penetrate. It seemed like the end. But Earth is a living organism. Volcanoes continue to erupt, spewing carbon dioxide into the atmosphere. With the oceans trapped beneath the ice, this gas couldn't dissolve and instead accumulated in the atmosphere, creating a powerful greenhouse effect. And one day, this warmth became sufficient to trigger the melting process. And then, approximately 540 million years ago, after the glaciers retreated, something incredible happened. Evolution seemed to break free. In a geological blink of an eye, a mere 20 to 30 million years, an astonishing diversity of multicellular animals appeared in the oceans. This event is known as the Cambrian explosion. The first creatures with hard shells and skeletons emerged alongside arthropods and the ancestors of mollusks and chordates. The oceans teemed with trilobites, resembling giant wood lice, predatory anomalocarids with claws near their mouths, and a multitude of other bizarre creatures. It was a true biological Big Bang, giving rise to almost all major animal phyla that exist today. Life was no longer just microscopic slime. It became visible, complex, and dangerous. The first true predators and their prey appeared, initiating an endless arms race. Over the next several 100 million years, life actively colonized new territories. First, plants ventured onto land. These were primitive mosses and lichens, which covered bare rocks with the first green carpet. They began to change the landscape and soil composition. Following the plants, animals also made their way onto land. Initially, these were arthropods, the ancestors of modern insects, spiders, and scorpions. And then, approximately 375 million years ago, the first vertebrates emerged from the water. These were fish with powerful fins that could crawl from one body of water to another. Over time, their fins evolved into limbs, and they became the first amphibians. The Carboniferous period, or Carbon, began. The climate was warm and humid, and atmospheric oxygen levels reached 35%, compared to our current 21%. The entire landmass was covered in giant forests of tree ferns and horsetails. Due to the excess oxygen, insects grew to monstrous sizes. Dragonflies with wingspans of up to 70 centimeters, and giant millipedes over 2 meters long. Enormous amphibians thrived in the swamps. It was from the remnants of these ancient forests that, over millions of years, the very coal deposits we utilize today were formed, but nothing lasts forever. 252 million years ago, the planet suffered the most catastrophic event in its history, the Great Permian Extinction. It was far more devastating than the one that wiped out the dinosaurs. Up to 96% of all marine species and over 70% of terrestrial vertebrates vanished from the face of the Earth. Life hung by a thread, teetering on the brink of complete annihilation. The cause was most likely massive volcanic eruptions in what is now Siberia. For hundreds of thousands of years, colossal amounts of carbon dioxide and methane were released into the atmosphere, triggering rapid warming, ocean acidification, and oxygen depletion. The planet was suffocating. It was the greatest filter in evolutionary history. But life, though with immense difficulty, survived. And in the desolated world, new players emerged. The Mesozoic era began, the age of dinosaurs. These reptiles, survivors of the extinction, were given a unique opportunity and seized it fully. For 180 million years, they were the undisputed masters of the planet. They conquered every habitat, from gigantic herbivorous sauropods whose necks towered above the trees, to fierce predators like the Tyrannosaurus, from flying pterosaurs to marine ichthyosaurs. Around this time, the first mammals emerged, though they were small, nocturnal creatures that hid in the shadow of the giant reptiles. The continents, too, were not idle. The supercontinent Pangaea, which encompassed nearly all land masses, began to break apart, its fragments drifting to form the outlines of today's continents. This geographic shift isolated populations and fueled evolutionary diversity. The dinosaurs' reign seemed eternal, but the cosmos had other plans. 66 million years ago, an asteroid the size of Mount Everest slammed into Earth in what is now Mexico's Yucatan Peninsula. The impact unleashed energy billions of times more powerful than all the nuclear bombs on the planet combined. The blast wave circled the globe multiple times. A colossal tsunami, hundreds of meters high, surged across the oceans. So much dust and soot from the planet-wide infernos were ejected into the atmosphere that sunlight ceased to reach the surface. An impact winter descended, lasting for years. Photosynthesis ground to a halt, plants withered, and food chains utterly collapsed. Dinosaurs, along with countless other species, could not survive this apocalypse. Their 180 million year era came to an abrupt end. Once more, a mass extinction cleared the way for those who managed to survive. In the ensuing Cenozoic era, or the Age of New Life, mammals seized their opportunity. From small and inconspicuous, they evolved into the planet's dominant animal group. Gigantic hornless rhinos known as Indricotheriums, saber-toothed tigers, mammoths, and woolly rhinos emerged. The planet continued its transformation. Continents settled into their current positions. The climate gradually grew colder and drier. Vast steppes and savannas replaced the once widespread tropical forests. These landscape changes then spurred the evolution of a particularly interesting group of primates in Africa. To escape predators in the tall grass, our distant ancestors, the Australopithecines, began to walk upright on two legs. This freed their hands for using tools, and their brains began to grow. Approximately 2.5 million years ago, the genus Homo emerged. Our ancestors learned to make stone tools and later mastered fire. They dispersed from Africa across the globe, adapting to new conditions. Species succeeded one another: Homo habilis, Homo erectus, Neanderthals. And then, approximately 200,000 to 300,000 years ago, our species, Homo sapiens, emerged in Africa. We proved incredibly successful. Thanks to our advanced intellect, complex language, and capacity for cooperation, we displaced other human species and populated every continent except Antarctica. About 10,000 years ago, we brought about another revolution, the Neolithic. We transitioned from hunting and gathering to agriculture and animal husbandry, began to build cities, create civilizations and empires, and develop science and art. In a geologically infinitesimal amount of time, we transformed into the planet's dominant geological force. We are changing the climate, altering landscapes, relocating species from continent to continent, and triggering a new sixth mass extinction. Some scientists even propose designating a new geological epoch, the Anthropocene, the age of humans. And so, in just a few minutes, we have whisked through 4.5 billion years. From a fiery ball to a blue planet, from the first living cell to billions of humans. The Earth's history is a grand saga of creation and destruction, of chance and patterns. It reveals how long and arduous the path to our appearance has been, and it also compels us to reflect on the future. The preceding chapters of this story were penned by volcanoes, asteroids, glaciers, and blind evolution. But right now, you and I are writing the new chapter, and what it will be depends entirely on us.